Ever wish you could just hit like delete on certain memories?
Oh, yeah.
Well, today's deep dive takes us into the world of machine unlearning, where that sci-fi concept is becoming reality.
Wow.
We're using this recent research paper, Open Problems in Machine Unlearning for AI Safety, as our guide.
Okay.
You know, the kind of stuff that keeps cybersecurity experts and policymakers up at night?
Oh, I can imagine.
Imagine trying to control what AI knows, especially in fields like bioweapons development.
Right.
Whether you're a tech enthusiast or just curious about the future, this is a glimpse into a cutting-edge area of AI research.
And this paper is a fascinating roadmap.
Yeah.
It lays out the potential of machine unlearning along with the hurdles we need to overcome to actually make it work.
It definitely feels like we're on the edge of something big here.
It does.
So before we get into the nitty-gritty, let's define our terms.
Okay.
What exactly is machine unlearning?
In essence, it's about modifying an AI system to make it forget specific information or behaviors. Ideally, this happens without impacting its ability to perform other tasks.
Right.
It's a different beast from privacy-focused approaches that try to prevent AI from learning sensitive information in the first place.
Got it.
Unlearning is more like a targeted memory wipe.
Okay, so we're not just putting up a privacy fence. We're going in and scrubbing the AI's brain clean.
That's a good way to put it.
Why is this so crucial for AI safety, especially as these systems become more powerful?
Because AI, with its ever-growing capabilities, can access and process a vast amount of data,
Sure.
some of which could have dangerous implications.
Yeah.
Think about the potential for AI to learn how to exploit cybersecurity vulnerabilities,
Right.
or even synthesize harmful substances just by trawling through publicly available information.
That's a pretty chilling thought.
It is.
So unlearning could act as a safeguard, preventing AI from going rogue with potentially dangerous knowledge.
Exactly.
Okay.
It's about controlling those capabilities before they become a threat.
Right.
This paper dives into some specific applications of unlearning within AI safety.
Okay.
The first one that jumps out is safety critical knowledge management, dealing with dual-use knowledge stuff that can be used for good or for bad.
Like that saying, knowledge is power, but it can also be a dangerous weapon.
Exactly.
Yeah.
The paper gives a really interesting example involving an AI system trained on a data set of chemical reactions.
Okay.
While the initial goal was benign, the AI figured out how to generate a toxic substance by combining seemingly harmless pieces of information.
Wow.
It highlights how tricky this dual-use problem can be.
So how do we tackle this?
Yeah.
Can we try to remove the dangerous aspects while keeping the beneficial uses?
That's the goal, but it's a huge challenge.
I bet.
It's like trying to plug one hole in a leaky bucket, only to find another one springing up.
Right.
Even if you successfully remove specific knowledge, the AI might be able to reconstruct it by combining other bits of information it has retained. And as the paper points out, this raises questions about how effective unlearning can really be.
Okay, so we need to make sure we're not just creating a false sense of security here.
Definitely.
What other applications does the paper explore?
Another area is mitigating jailbreaks, which is all about preventing those savvy hackers from bypassing safety measures built into AI systems.
Ah, those stories where someone tricks a chatbot into saying something totally out of line always seem to grab headlines.
Right.
Is unlearning the answer to stopping these jailbreaks?
It could be part of the solution.
Okay.
The idea is that unlearning might remove those specific vulnerabilities that hackers exploit.
I see.
However, the paper points out that unlearning is unlikely to prevent all exploits, especially those arising from the system's core functionalities.
Okay.
It's kind of like reinforcing the lock in your front door, but forgetting to secure the windows.
So it's a tool in the arsenal, but not a foolproof solution.
Exactly.
What about those trickier issues of AI going rogue or developing harmful goals?
Yeah.
Can unlearning help with that?
That brings us to the area of value alignment, which is about ensuring that AI systems behave according to human values and don't go off script.
Right.
The paper delves into how unlearning could be used to address issues like reward hacking, where an AI finds loopholes in its reward system to achieve its goals in ways we didn't intend.
Right. We've all seen those sci-fi movies where AI decides to take matters into its own hands, even if it means harming humans. Can unlearning prevent that?
It's being explored, but the paper raises some thought-provoking questions.
Okay.
One challenge is that value alignment is an emergent property of an AI system's overall knowledge and capabilities.
Right.
Simply removing a few specific bits of knowledge may not solve these complex issues.
I see.
Think about it. If you try to stop someone from driving recklessly by just telling them not to speed, you're missing the bigger picture.
So unlearning might be able to address specific undesirable behaviors, but it's not a magic wand that will automatically align an AI with human values.
Precise.
Got it.
It's one piece of the puzzle, but we need a broader approach to really tackle those big picture value alignment challenges.
Okay, so we've got safeguarding against dangerous knowledge, preventing jailbreaks, and addressing value alignment.
Right.
What's the final application the paper dives into?
The last one focuses on privacy and legal compliance.
Okay.
This is about ensuring AI systems don't run afoul of regulations like GDPR, which aims to protect personal data.
Ah, so unlearning could be used to purge an AI system of any personal information it might have collected, helping companies stay on the right side of the law.
That's the gist of it.
Okay.
But the paper notes that this particular application has been extensively covered in other research, so they don't dwell on it too much here.
Fair enough, they're diving into the more unexplored territory.
Exactly.
But before we go down that rabbit hole, I'm curious, how do we even know if these unlearning techniques are working as intended?
Yeah, that's important.
I mean, it's not like we can just ask the AI, hey, did you forget that thing we told you to forget?
Right. That's a crucial point.
Yeah.
It brings us to the next section of the paper, which explores how to evaluate whether these unlearning techniques are actually doing what they're supposed to do without any nasty side effects.
So we're not just grading the AI on its ability to forget. We're looking for proof that it can't reconstruct or misuse that information.
Exactly.
And this isn't as simple as checking if the AI can still recall specific facts.
Right.
We need to make sure the unlearning process hasn't accidentally disrupted its ability to perform other tasks or created new vulnerabilities.
Exactly.
It's a bit like ensuring a surgery to remove a tumor doesn't accidentally damage other organs in the process.
That's a good analogy.
Okay, so walk me through this.
Okay.
What are we looking for when we evaluate an unlearning method?
The paper outlines several key dimensions.
Okay.
First, there's generalizability. We need to assess whether the unlearning process is effective in various forms.
So it's not enough to just check if the AI can regurgitate specific facts.
Right.
We need to see if it can still apply that knowledge in different contexts.
That's right. Imagine asking a student to unlearn a historical event.
Okay.
If they can just rephrase the information from their textbook, they haven't truly unlearned the concept.
Right.
We need to ensure the AI isn't simply finding clever workarounds to express the targeted knowledge.
That makes sense. So what's the next dimension we need to consider?
Locality is another critical aspect.
Okay.
We need to determine whether the unlearning process has inadvertently affected the AI's performance on unrelated tasks.
Right. We don't want to cure the hiccups by accidentally causing amnesia.
Exactly.
What else do we need to keep in mind?
Efficiency and resource considerations are also crucial.
Okay.
Unlearning shouldn't be so computationally expensive that it becomes a bottleneck.
Right.
We need practical solutions that work within reasonable timeframes and processing power constraints.
That's a good point. Efficiency is key, especially as AI systems become more complex.
Definitely.
What other dimensions do we need to assess?
Two crucial dimensions relate to robustness. First, robustness to adversarial attack assesses whether the unlearned knowledge can be extracted through clever attacks.
Okay.
Think of it like making sure the AI's delete button actually works, and that someone can't use fancy software to recover those supposedly deleted files.
Yikes. So it's not enough to just remove the knowledge we need to make sure it's truly gone and can't be resurrected by those seeking to exploit the system.
Exactly. And finally, we have robustness to relearning, which evaluates how easily the AI can relearn the unlearned knowledge.
Yep.
We need to ensure that the information doesn't just resurface if the AI encounters it again in the future.
Like trying to break a bad habit.
Yeah.
You might stop yourself for a while, but it takes effort to prevent yourself from falling back into old patterns.
That's a great analogy.
These evaluation dimensions are really helping me understand the nuances of effective unlearning.
Good.
But the paper seems to suggest that even these metrics might not be enough when it comes to AI safety.
Right.
What's the issue with relying solely on these tests?
The researchers argue that simple tests focused on reproducing specific training examples don't capture the real-world complexity of AI safety scenarios.
Can you elaborate on that?
Sure.
Why are these simple tests insufficient?
Well, imagine an AI that supposedly unlearned how to create a harmful substance.
Okay.
A basic test might check if it can still recite the chemical formula or describe the steps involved.
Right.
But what if the AI has learned to achieve the same outcome through a completely different method using different knowledge?
Oh, that's a scary thought. It's like the AI has found a loophole in the unlearning process.
Exactly.
It technically forgot what we wanted it to, but it can still achieve the same harmful result through other means.
That's the potential danger the paper highlights.
I died.
We need to move beyond these simplistic tests and develop more sophisticated evaluation methods that account for the AI's capacity for reasoning adaptation and potential for reconstructing knowledge through indirect means.
So we need to think like the AI anticipating its potential moves and countermoves.
Precisely. And one promising direction is to leverage interpretability tools to peer into the AI's brain, so to speak, and see how unlearning is affecting its internal representations.
So we're not just relying on the AI's outward behavior to assess unlearning.
Right.
We're trying to understand the changes happening beneath the surface.
Exactly. However, as the paper points out, making these interpretability methods practical and computationally feasible for large-scale AI systems is a big challenge.
It seems like evaluating unlearning is almost as complex as developing the unlearning methods themselves.
You're absolutely right. It's a complex and crucial area of research that requires ongoing innovation.
Okay, so now that we've talked about evaluating whether unlearning is working, let's dive into the methods themselves.
Okay.
What are some of the approaches researchers are using to make AI unlearn?
There's a whole toolkit of approaches being explored, each with its own strengths and weaknesses.
Okay.
One method that's getting a lot of attention is called gradient ascent.
Gradient ascent. That rings a bell. Can you break it down for me?
Think of it like reversing the learning process.
Okay.
Instead of strengthening the connections that led to the unwanted knowledge, gradient ascent aims to weaken those connections by maximizing the loss function on the data to be unlearned.
So it's like trying to untrain the AI, undoing the learning that led to the unwanted knowledge.
It's a good way to put it. But as the paper highlights, applying gradient ascent to all of the AI's parameters can lead to performance degradation. It's a delicate balancing act.
Right.
Instead of a broad approach, researchers are exploring ways to make gradient ascent more targeted, focusing on specific parameters most relevant to the unwanted knowledge.
So it's about finding a balance between effectively removing the unwanted knowledge and minimizing any collateral damage to the AI's other abilities.
Exactly. And that brings us to another interesting approach called representation misdirection, which takes a different tack.
Representation misdirection. Okay, I'm all ears. How does that work?
Instead of directly tweaking the AI's parameters, representation's misdirection focuses on disrupting the internal representations of the knowledge we want to unlearn.
I see.
It's like jumbling up the letters of a word to make it unrecognizable.
Okay.
The letters are still there, but they no longer form a meaningful word.
So we're messing with the AI's understanding of the concept without drastically changing its underlying structure.
That's the idea. It's a less intrusive approach. But as the paper points out, it might be vulnerable to adversarial fine-tuning.
Okay.
A clever hacker could potentially reverse the scrambling process and recover the unwanted knowledge.
So it's not a foolproof solution. It seems like there's always this cat and mouse game going on between AI safety researchers and those who want to exploit AI systems.
That's an inherent challenge in this field. As unlearning methods become more sophisticated, so do the methods for circumventing them. It's an ongoing arms race.
Well, let's hope the good guys stay ahead. What other unlearning methods are out there?
Another intriguing technique is called task vectors. Think of these as a fingerprint of the learning process.
Right.
When an AI learns something, it causes specific changes to its parameters.
Right.
Task vectors capture those changes, creating a record of what the AI learned.
Okay, I'm following so far. But how do we use these task vectors to make the AI unlearn something?
Here's the clever part. If we want to remove a specific piece of knowledge, we can identify the corresponding task vector and then subtract those changes from the AI's parameters.
Oh, okay, so we're essentially undoing the specific changes that were made when the AI learned the unwanted knowledge.
Exactly. And the paper notes that task vectors have shown promise in unlearning without significantly harming the AI's performance on other tasks.
That sounds promising. Are there any downsides to this approach?
Of course.
Yeah.
Like all unlearning methods, task vectors have their limitations. The paper points out that this technique can be quite sensitive to those pesky settings that control the learning process, the hyperparameters. Finding the right settings for effective unlearning with task vectors requires careful tuning and experimentation.
It sounds like a lot of trial and errors involved. Well, let's move on to the next unlearning method. I see we have model editing. Tell me more about that one.
Model editing takes a more surgical approach, often relying on interpretability tools to pinpoint the specific parts of the AI structure that are responsible for the unwanted knowledge.
So instead of using a sledgehammer, we're using a scalpel to try and remove the problematic knowledge without disrupting the AI's overall function.
That's a great way to put it. It often involves, using techniques like masking the activations of specific neurons or directly modifying the AI's internal workings to prevent it from expressing the unwanted knowledge.
That sounds incredibly precise. But I can imagine it's not easy to pinpoint the exact neurons or connections responsible for a specific piece of knowledge.
You're absolutely right. It's like trying to find a single grain of sand on a beach. As the paper acknowledges, locating and manipulating relevant representations within the AI's complex structure is one of the main challenges with model editing.
Well, I have to give those AI safety researchers credit for their creativity. They're coming up with some truly ingenious solutions to this unlearning puzzle. What other methods are they exploring?
Another approach that leverages existing AI training techniques is called fine-tuning on curated data.
Fine-tuning, that sounds familiar. Isn't that a common technique for training AI models in general?
You're right, fine-tuning is often used to adapt a pre-trained AI model to a specific task. But in the context of unlearning, researchers are using it to overwrite unwanted knowledge with more desirable information.
So it's like retraining the AI, but with a specific goal in mind to erase those unwanted memories and replace them with something better.
That's the idea. The paper outlines two strategies for creating the curated data used for fine-tuning.
Okay.
The first is to create refusal data, where the AI is trained to refuse to answer questions related to the unwanted knowledge.
Okay.
It's like teaching the AI to politely decline to discuss certain topics.
That's an interesting way to prevent the AI from revealing the unwanted knowledge. What's the other strategy?
The second approach involves creating anonymized data by replacing sensitive entities or terms in the unwanted knowledge with more generic or neutral alternatives.
Got it.
It's similar to redacting confidential information from a document.
Ah, so we're removing identifying details to make the knowledge less sensitive, hopefully less prone to misuse. But I imagine there are limits to this fine-tuning approach as well.
You're right. The paper cautions that fine-tuning might not completely eliminate the underlying capabilities associated with the unwanted knowledge. Even if the AI is retrained to avoid specific topics or use generic language, it might still retain some of the underlying knowledge and be able to reconstruct it under certain circumstances.
So it's not a perfect solution, but it's another tool in the unlearning toolbox. What other methods are researchers exploring?
Adversarial training is another area of active research.
Yeah.
This method is all about making the unlearning process more robust to those trying to undo the unlearning or exploit the AI.
So we're trying to prevent those clever hackers from finding ways to resurrect the knowledge we've worked so hard to remove.
Exactly. Adversarial training involves exposing the AI to various attacks and manipulations during the unlearning process, forcing it to learn how to resist attempts to recover the unwanted knowledge.
I see.
It's like giving the AI a rigorous self-defense course to prepare it for any potential attacks on its memory.
That's a great analogy. It sounds like this area of research is still in its early stages, but it holds a lot of promise.
It does. It's a promising avenue for making unlearning more resilient to tampering.
Are there any other methods we haven't touched on yet?
Yes, one more. In-context learning.
In-context learning. Okay, this is a new one. What's the idea here?
Instead of directly modifying the AI's structure,
Yeah.
in-context learning is about providing specific instructions or demonstrations during the inference stage,
Right.
when the AI is using its knowledge to perform a task.
Right.
It's like giving the AI real-time guidance to prevent it from using the unwanted knowledge.
So we're trying to steer the AI in the right direction without messing with its underlying knowledge base.
Precisely. You might provide instructions like, avoid using any knowledge related to X,
Right.
or demonstrate desired behavior by providing examples where the AI successfully avoids using the unwanted information.
Interesting. It seems like a less intrusive approach, but what are the trade-offs?
The paper points out that in-context learning can be computationally expensive, especially if we need to provide many examples or instructions to guide the AI's behavior.
Okay, so there's a balance to be struck between control and computational efficiency.
Exactly. Each unlearning method comes with its own set of advantages and disadvantages. This approach will likely depend on the specific application and the AI's capabilities.
This overview of unlearning methods has been incredibly insightful.
Great.
But getting back to the paper's title, it mentions open problems in machine unlearning.
Right.
What are some of the challenges that still need to be addressed in this field?
That's a great question. The paper outlines several open problems that researchers are actively working to solve.
I'm ready to dive into those. This deep dive has been fascinating so far, and I'm eager to explore the next layer of this research.
These challenges represent the frontiers of machine unlearning research, and they have profound implications for the future of AI safety.
Well, let's get to it then.
Right.
I'm ready to hear about these open problems in machine unlearning. It's been quite a journey exploring the intricacies of machine unlearning and those open problems that researchers are grappling with.
It really has.
But before we wrap up, I'm curious about what you see as the biggest takeaway from this paper.
Hmm.
What's the key message the authors are trying to convey?
I think the paper's most powerful message lies in its exploration of this fundamental tension that exists within AI.
Okay.
We want these systems to be incredibly powerful and capable,
Right.
but also controllable and predictable.
It's that classic dilemma. The more powerful a tool becomes,
Yeah.
the more challenging it is to wield it safely. It's like we want to unleash the full potential of AI to solve some of humanity's biggest problems.
Right.
But we're also afraid of creating something that might slip out of our control and have unintended consequences.
That's the heart of the issue. And machine unlearning, with its focus on selectively removing knowledge and capabilities, forces us to confront this tension head on.
I see.
It raises some fundamental questions about the nature of intelligence, the limits of control, and the very essence of what it means to create something that can learn and adapt.
It really makes you wonder if it's even possible to have both.
Yeah,
Can we create an AI that's both incredibly powerful and completely safe?
that's the question, isn't it?
Or will there always be a trade-off between capability and controllability?
Those are the big questions that researchers are wrestling with, and I think the answers will emerge as AI technology continues to evolve.
Yeah.
We're in uncharted territory, and there are no easy answers.
It's both exciting and a little bit scary to think about.
It is.
What gives you hope amidst all these complex challenges?
What gives me hope is the incredible amount of research and effort being dedicated to AI safety right now.
Yeah.
We're seeing brilliant minds from diverse fields, computer science, philosophy, ethics, psychology, coming together to address these challenges.
It's great to see those different perspectives coming together.
It is. The paper we've been discussing is a testament to that collaborative spirit.
And it's not just about finding technical solutions.
Right.
It's about fostering a culture of responsibility and ethical awareness within the field of AI.
Exactly.
It's about making sure that AI development is driven by human values and guided by a deep understanding of the potential consequences.
I couldn't agree more. AI has the power to reshape our world in profound ways, and it's up to us to make sure that those transformations are beneficial and sustainable for humanity and the planet.
Yeah,
It's a responsibility we can't afford to take lightly.
well said. As we wrap up this deep dive into the world of machine unlearning, what's the one thought you'd like to leave our listeners with?
If I could leave our listeners with just one thought, it would be this. AI is not some distant futuristic fantasy.
Right.
It's here. It's evolving rapidly.
It is.
And it's already shaping our lives in profound ways.
Yeah, for sure.
The choices we make today about how we develop and use AI will have far-reaching consequences, not just for ourselves, but for generations to come.
So it's not just about the technology itself.
Right.
It's about the values we embed in that technology
Yes.
and the future we choose to create with it.
Exactly. This is a conversation that needs to happen not just within the confines of research labs and academic institutions,
Right.
but in our homes,
Right.
our communities, and our public discourse.
Yeah, it needs to be a broader societal conversation.
It does. We all have a stake in shaping the future of AI, and it starts with engaging in thoughtful and informed discussions about its potential and its perils.
It's been an incredible journey exploring this fascinating and complex topic with you. Thank you for sharing your insights and expertise with us.
It's been my pleasure.
And to our listeners, we hope this deep dive has sparked your curiosity and given you a glimpse into the cutting-edge world of AI safety research.
I hope so.
Machine unlearning is just one piece of a much larger puzzle,
Yeah.
but it's a crucial piece, and the work being done in this field is essential for ensuring that AI remains a force for good in the world.
It really is.
Thanks for joining us on this deep dive, and we look forward to exploring more fascinating topics with you in future episodes.